Hey everybody, here I have a fresh Dremio environment with a few sources connected to give you an idea of just how you can work with Dremio to kind of federate different sources. So let's kind of go through the different sources that we have. So we have a Nessie catalog connected that acts as sort of our iceberg catalog that we can write icebergs to, sort of interact with it, kind of like a database that we can read and write tables to. We have a Minio connection that's connected to Minio to act as object storage to store files like so I could store CSV, JSON files on there and then query them from here in Dremio. I also have a connection to a Mongo database and a Postgres database. And this is all running from my laptop. The actual Docker compose file to create this environment will be linked to in the video description. But in the Mongo environment, I have this database here, my database that has this table called customer preferences. And in the Postgres table, I have these two tables here that have my list of customers and their orders. So imagine you don't have Dremio. What would you have to do? You'd have to kind of more painstakingly connect to these different sources and move that data to somewhere else so you can join them together. So typically probably what you would do is you maybe load them into Python data frames, join them, and then load them into some other system. Here I can work with it without necessarily having to load that data into another system, without having to duplicate it, without necessarily having to know Python. Okay, just some basic SQL. So for example, here is the query to join the data. So in this case, this is joining all the tables from Mongo and Postgres. And there it is. Now imagine this is a much bigger table. And this joins on much larger tables might take some time. So what if I want to accelerate this? How? There's two different ways I can kind of do this. Okay, what I could do is I could turn this into an iceberg table. So what I can do is run a create table as statement. So create table as, and then essentially, first I have to get the table name. So that would be in our Nessie because it's going to be an iceberg table. So it's going to be in our catalog. So we'll call it like Nessie dot customers, customer info as select. So essentially what it's going to do is going to create this table, and then this table is going to be the result of this query. Okay, so I could run this, which we will. Okay, and that's going to write that table. Give it a moment to do that. Okay, and there it is. It created the table. So now if I head over to my Nessie source here, there's the table, customer info. And now I can query that pretty fast, and no join has to be done because the data, basically the post join data, is now manifested into its own table. Now this can be fine in some situations. The only problem is that what happens if those underlying tables update? I would have to then go back and rerun this to recreate that table, which may or may not be the right way to do things, depending again on your particular use case. Dremio has another really cool option that will essentially get you to the same place, but you don't have to worry about those updates. So that as those underlying tables in Postgres and Mongo change, Dremio will handle the updating of the materialization. So now if I go back over here to that query, so let me go back right over here where that query is. So we'll go back to just the select query. What I can do is I can take this query. Right now what I could do is I could save it as a view actually. So I can go here and say I want to save it as a view, and I can say, and you can actually save views in your Nessie catalog. So I could say, hey, this is customer view. And again, this is just a SQL view. So this is not a copy of the data. Okay, so now my users, they don't have to rewrite that join anymore. They can just go to the Nessie catalog, find the view, and you can notice that it's different because it's green. Green is views. Purple are physical tables, meaning they're actual copies of the data. Here you see a view, and I can go to that view, run that query, but in this situation, you are still running the join again. Okay, but again, you can create all these views for all the different versions of the data that your users need, and basically everything is kind of already set and ready for them. But what if I want to accelerate this particular view? What I can do is I can click right over here on Edit, and it's going to take me to this screen right over here. And you'll see there's a feature called Reflections. Okay, now if I click a raw reflection, what this is going to do is create a copy of the raw result. So I hit save. That's going to create a reflection. So right now it's essentially creating that same iceberg table we created before, but it's creating it as a reflection, meaning it's not its own table. It's this physical copy that's stored on our data lake, which in this case is Minio, um, and basically used when we query that table. So now watch what happens if I go back and query that view again. So I go back to Nessie. I'm going to query the view, and I'm going to hit run. Okay, and then the query is done. Now again, it ran pretty fast before because again it's a smaller data set. But theoretically, this was a much larger table. The whole join would be skipped because Dremio behind the scenes knows that there's this reflection that's stored on your data lake that it can use that's already pre-joined. And periodically, it'll go back and rerun the query and update and refresh that materialization. So the end user doesn't have to query another table. They query this view just like they were querying before, but it's now just faster. Okay, and if I go over here to the jobs, so notice that before we created the reflection, you see that there's no little lightning symbol here. That means it did the full query. Okay, but then after I created the reflection, it does use the query. So the query was accelerated. So the difference is it didn't have to rerun all that logic again. It just went over to storage, got the pre-computed results, and life was good. And in this case, I don't have to have two tables. That one table can basically still is not just faster. Okay, so instead of having to like physically create another table and my user having to know, hey, go query this other thing, the thing that they were already querying is just faster. So one of the benefits of this pattern. And again, you can very much control and like, for example, organize your data sets. So you can organize physical iceberg tables here in your Nessie catalog or views in this catalog, and I can organize them. So let's say I want to organize it by department and say, hey, here's accounting. Here is product. Here is marketing. Here is sales. I can then now, when I save my views and create my views, I can create them in this folder and create in a nice organized, semantically thought of, aka a semantic layer that allows all my data assets to be easily discoverable by users. And again, on any of these data sets, I can go over here and let's say I go to customer info. Okay, I can give these labels. So I can go give this a label and say, hey, this is customer. And that gives it that label now. So now what happens, I can easily search for that data by just typing in customer. And when I type in that customer tag, data sets that either have a same name or have that tag will show up, and I can easily find data sets that I'm looking for. So Dremio makes it really easy for that end user to work. All they need is have maybe some basic SQL skills, but even then they don't have to. For example, if we wanted to create this join between those tables, okay, this join here, we could have actually just, I need to take this off. What happened there? Oh, forgot to take the word as off. See, yay for informative errors. Okay. So now what I could do is I can click like these group bys to do like aggregation queries. I can click add column to do joins. So that way people who aren't necessarily as smooth with SQL can still do a lot of that SQL work, whether it's adding generated columns, joins, group bys, be able to kind of do that type of logic without necessarily having to be SQL masters. Although again, a little bit of SQL can go a long way, never hurts. And again, it's still a lot easier than probably, creating a Python environment, loading up the data into different data frames, then joining the data frames, and then pushing that data into some other system for those who are less technical users. So hopefully you guys enjoyed this. My name is Alex Merced, developer advocate or senior tech evangelist here at Dremio, and I'll see you all in the top with more cool examples.